date today? 10. Uh-oh. 10-9. All right, we're in 3-1 continued. And inequalities in their graphs. Inequalities and graphs. All right, today you're going to be given an inequality, something like n is less than 1, and you're going to be asked to graph it, or you're going to be given a picture of the graph, and you're going to be asked to write the inequality. Okay, a couple things you need to remember. On the number line, if you're going to graph n is less than 1, what you're graphing is everything, all the solutions to this inequality. And the solutions are, who remembers what the solutions are? Come on, Dan? Good. The solution is the values that make the inequality true. Okay? So, when you're graphing inequalities in here, don't overdo it on the graphs. This is all that I require. I require the number that's in the inequality, and I require 0. Okay? Make sure that you put 0 on the number line where it goes in relation to the number. Clear? Then, when we're graphing everything less than 1, that is an open circle on 1. The open circle means we don't include the 1. We're not including it, okay? And now, less than is going to be to the left. So a little squiggly line and an arrow. The squiggly line means those are the numbers we're including. The arrow means keep going forever. Okay? Fair enough? Now, if this was n is less than or equal to 0, or equal to means fill in the 0 because we're including that number. No. No. Not for or equal to. For or equal to, it's closed. Okay? For or equal to, it's closed. I just didn't want to draw a whole nother graph to tell you to close it if there's a line under it. Alright, now look. This is the way you're used to reading this, right? Where's the variable? On the left. The number is on the... This will start getting confusing in a little bit and later on in the year, but I want to tell you this now. If it looks like the way you're used to seeing it, variable on the left, number on the right, then you always shade the direction that the inequality is pointing. Okay? If this says x is greater than -3, okay, we put a line, we put -3 on it, we put 0 on it. Okay? Now, open or closed? Open. Open on 3 and going which way? To the right. If the variable's where you're used to seeing it, you shade the direction that the inequality is pointing. Okay? If the variable's where you're used to seeing it, shade the direction the inequality is pointing. Some people get confused when... Now, the variable's not where it usually is it? That's not what you're used to seeing. So if it's not what you're used to seeing, we still put the -2 on there. We still put 0 on there. But now, open or closed? Closed, because it's or equal to. Okay? Now, if the variable's on the opposite side that you're used to seeing it on, shade the opposite direction of the arrow. So now you would shade to the right. Confusing, isn't it? Okay? It gets confusing when the variable's not on the side that you're used to seeing it. Okay? Because this reads -2 is less than or equal to all the solutions, right? Well, there's -2. It's smaller than all the solutions, isn't it? But if you'll just remember, if the variable's on the opposite side, shade the opposite direction. If the variable's on the side you're used to seeing it, shade the direction that the inequality is pointing. Okay? Try a few more. All right. 5 greater than or equal to b. Do what you know first. Put the 5 on there. Put the 0 on there. Okay? What are you going to do at the 5? Open or close? You're going to close it at the 5. That should be a no-brainer. Now what you want to do is look at the inequality. Is the b on the normal side or the opposite side? It's on the opposite side. So what direction are we going to shade? Say the opposite direction. It's pointing to the right, so we're shading to the left. Okay? X is less than 7. Graph it. Now you look at a graph. Oh, well, that's a bad graph. Woohoo! Now I'm giving you the graph, and you got to write the inequality. Any volunteers? Go ahead, Taylor.
T is less than 3 greater than.
Very good. Now,
Can I do it such a other? If 1/2 is less than t.
yes. Which one of those is right? They're the same, aren't they? Isn't the arrow pointing towards the 1/2 both times? So they're both the same. I got a little trick the way I do it. I like to do it when I see the number line and whatever it's got on it, -2 and 0. Say it's closed and going this way. I just like to put a letter and the number that's on the graph. And I do it the way I normally see it. Right? And then I look which way is shaded, and that's which way my arrow's got to point. And if that's closed, I'll put a line there. And I'm done. That's pretty easy, isn't it? Yeah. So, try it. See how easy it is that way. Does it matter what letter you use? It doesn't matter what letter you used. Open or closed here? Going which way? Pretty simple? Do we need to spend a whole day on that? No. I don't think so either. Oh! I turned the page and it came out. That is wrong. Alright, we're going to... Another page just came out. What the heck is going on here? Alright, we're going right into solving them, guys. We're not going to spend a whole day on graphing them. Okay, solving using addition and subtraction. Alright, if you got to solve something like 13 is less than or equal to m plus 12, you treat it just like an equal sign. Okay? You treat it like an equal sign. You subtract 12 from each side. 13 minus 12 is 1. You keep everything the same. Keep the symbol the same. Less than or equal to m. That's it. You put a big note. The only time I change the direction of the inequality is when I divide or multiply both sides of the equation by a negative. That's like super, 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 as you would hashtag it or whatever you do, important. Okay? Really important. Alright, an example of that would be an equation like negative m plus 6 is less than or equal to 12. Right here, you would subtract 6 from both sides, wouldn't you? And you'd be left with negative m is less than or equal to 6. And you're not done, are you? Because you don't leave a negative in front of the variable. So to get rid of the negative, you would divide each side by negative 1, wouldn't you? You would divide both sides of the equation by negative 1. If I divide both sides by a negative, I got to change the direction of the arrow. Okay? Anytime you multiply or divide both sides of the inequality by a negative, you got to change the direction of the arrow. Okay? Then if you graphed it, put it on a graph, you got your negative 6, you got 0, open or closed, closed. All right, the M is where we're used to seeing it, so which way do we shade? To the right. Very good. You guys all right with that? Yeah. Okay. Page 187 today. Be sure to read the directions because the directions say solve each inequality, graph, and check your solutions. Make sure you solve it and make sure you graph it, okay? And this is what I'm talking about for a graph. It shouldn't take you any more than about 5 seconds to graph it. But graph it right with your solution. Page 187, 13 through 21. And then 26 through 34. Just hope that those stay in there till next year. I think we'll get new books next year, though.